Imagine floating above Mars, gazing down at its rusty surface. Instead of just craters and dust, you spot enormous, intricate patterns, giant spider webs etched into the ground. These aren't spun by Martian creatures, but they're one of the planet's deepest mysteries. NASA's Curiosity rover first revealed these web-like shapes, stretching for hundreds of meters, forming geometric patterns almost too perfect to be natural. Scientists were baffled. What could create such regular, structured designs? They're not artificial, but the work of Martian nature, hinting at a forgotten chapter in the planet's history. These formations are clues, pointing to a time when Mars was very different, possibly wet, dynamic, and maybe even habitable. For years, Mars was thought to be a dead world, but discoveries like this reveal a complex, active past. These webs are more than patterns. They're evidence of ancient processes involving water, rock, and time. By studying them, we glimpse a Mars that may have once had flowing water and the right conditions for life. Every new image from Curiosity adds a page to this unfolding story. The mystery of the Martian spiderwebs is the mystery of Mars's lost, watery past, and solving it could bring us closer to answering, are we alone in the universe? As Curiosity approached, the webs became ridges of rock, tough, crisscrossing walls only centimeters high, but stretching for meters. Scientists call these formations boxwork because their intersecting ridges form angular, honeycomb-like grids. Walking through this landscape, you'd see sharp-edged rock walls forming triangles, squares, and polygons. These boxwork patterns are found high on Mount Sharp, a 5-kilometer mountain in Gale Crater. Each layer Curiosity climbs is a chapter in Mars's history, and finding boxwork so high up suggests these conditions lasted a long time. The ridges are made of minerals harder than the surrounding rock, which has eroded away over millions of years. Imagine cutting deep grooves in mud, filling them with cement, and letting the mud wash away. The cement grid remains. That's what happened on Mars, but over geological timescales. The original rock was like the mud, and the mineral cement was deposited by water. The relentless Martian wind then eroded the softer rock, leaving the hard ridges standing. These features are not just alien. They're familiar to geologists on Earth, always telling a story about water. The boxwork is a fossilized record of Mars's watery past, and it's one of the clearest signs that water once shaped this landscape. How did these spider webs form? The story starts billions of years ago, when Mars was much wetter. Gale Crater likely held a lake, where layers of sediment settled and turned to rock. Over time, the rock fractured, maybe from drying, shrinking, or even Marsquakes, creating a network of deep cracks. Groundwater rich in minerals seeped through these fissures, slowly depositing hard minerals and filling the cracks. The result, veins of tough material embedded in softer bedrock. As Mars dried and lost its atmosphere, wind erosion took over, scouring away the softer rock. The hard mineral veins resisted erosion, emerging as ridges on the surface. What was once hidden underground became a visible network of rocky walls. These spiderwebs are the fossilized plumbing of ancient Mars, a record of water that once flowed deep below. Today, they offer a snapshot of Mars's lost, watery world, and they're a key to understanding the planet's dramatic transformation. The discovery of boxwork is a breakthrough for scientists searching for past life on Mars. Why? Because water is essential for life, and these webs are clear evidence that liquid water persisted on Mars for ages. The process that formed them required water flowing underground for long periods, raising the odds that Mars was once habitable. Their location high on Mount Sharp means water was present even in younger rock layers, suggesting Mars stayed wet longer than we thought. Curiosity's onboard lab has detected clay minerals and carbonates here, minerals that form in neutral, life-friendly water. This hints at a stable, potentially habitable environment, not just a brief wet phase. The rover also searches for organic compounds, the building blocks of life. While not proof of life, finding them in these ancient, watery rocks would be a huge clue. Every drilled sample is a potential treasure chest, holding secrets about Mars's chemistry and its potential for life. The evidence is mounting. Mars was once a world where life could have thrived, and the Boxwork formations are among the strongest clues yet. They're a window into a time when Mars was alive with water. Let's be clear, we haven't found life on Mars. Not yet. The spider webs aren't the work of Martian creatures, but they're powerful clues. They show Mars once had water, minerals, and energy, the ingredients for life. Curiosity's mission continues, climbing Mount Sharp and exploring younger layers for more evidence. Each new discovery is a piece of the puzzle, revealing Mars's complex history. The search for organic molecules goes on, with hopes of finding a well-preserved rock that holds the ultimate clue. These Boxwork formations help frame the bigger picture. Mars was once dynamic, possibly habitable, and full of surprises. The journey is long, but every sol brings us closer to answers. The quest for life on Mars is one of humanity's greatest adventures. As we keep exploring, the mystery of the Martian spiderwebs brings us closer to understanding what makes a world truly alive. And we won't stop searching until we find the answer.